Okay, everybody, let's take a look at the last section that we're going to be studying for this chapter. It's going to be section 29H.3 and 29I, and it's going to be calculating continuous random variable values and applying the normal distribution. Okay, let's go ahead and kind of make sure that we can see everything very easily. We have the normal distribution, which what we said is going to have a continuous random variable of x. The mean is going to be greater than 0, and the standard deviation is going to, the standard deviation is also going to be greater than 0. Okay. On the flip side of things, when we talked about the standard normal distribution, notice that we talked about a different variable which was called z. We said that for all cases, the mean will be 0, and the standard deviation will always be 1. And remember that we said in order to calculate the normal distribution, we can just use the normal cumulative distribution function, parentheses, upper, lower, the mean, and the standard deviation. But if we did the standard, if we wanted to calculate it using the standard normal distribution, all we really needed to put was the upper and the lower bounds. Now remember, the reason why we actually had these two formulas was that we actually were trying to answer the question, what is the probability of x, say for example, being greater than a? Could have been x being greater than b, could have been the probability between a and b, but basically what we're trying to do is we're trying to calculate what the probability was. Now in this particular section we're going to be doing some of that, but in addition to that, we're going to be asking a different type of question. The question that we're asking is, what is the value of a if the probability is such and such? Okay? Now, in order to do that, we need to actually use what is called the inverse norm function on our calculator. And so what that does then is, say for example, when we did this way, you had a, you went to the probability. The inverse norm, of course, is going to go from the probability and give you back the value of a, which is what the inverse does. So, of course, if we take a look at the normal distribution, we have the percentage, comma, the mean, and the standard deviation, being that these two could differ for every particular case. But if we take a look at the standard normal distribution, being that we know that the mean and the standard deviation are always going to be 0 and 1 respectively, calculating the inverse norm is as simple as putting the percentage there to come up with the value that you're looking for. Now, that's the primary difference between those two. The normal cumulative distribution function will give you a probability given in A. The inverse function will give you a value of A if you know the probability. Okay, now another big difference that you need to remember is that with the calculator, of course, use this. It's going to be very simple for us to go ahead and calculate either the percentage or the values of A. Whereas if you don't have the calculator and you need to use a table, then of course you always have to refer back to the standard normal distribution. Okay, and what is the relationship between those two, especially if you don't have the calculator and you only have the table, is you have to remember this very, very important relationship between z and x. Okay? Now, let's just take a look at an example of how we do it using both the calculator and using just the table. Now, of course, I'm going to use the calculator a little bit there, but we'll be able to take a look at that a little bit more in class as to how to use it with just the table. Here's the example. Let's say, for example, that the height of 8-year-olds are normally distributed with a mean of 70 centimeters and a standard deviation of 3 centimeters. Okay, 90% of all 8-year-old children are all tall. So what we're saying then is we're not asking for what is the probability, we're actually given the percentage and we want to find out what the value of A is. And I'm hoping that everybody can see the difference with this question and this question. This question really is this type of question here. So let's take a look at our initial statement. Our initial statement basically is saying what is the probability of a particular value, height of a child, if that value is greater than A, and we know that that's going to be 90% of it. Okay? So again, being that we have our calculator, we can very easily go ahead and say that the A value, or the height of the children, is going to be the inverse norm, 90%. This is going to be the mean here, which we know is going to be 70. And we know that the standard deviation is 3. Pop that into your calculator and sure enough you get the value of A. So I know then that if a child is more than if a child is, wait, sorry, or how tall, sorry, this has to be less than. So 90% of them are how tall? So we know then that, for example, that if a child is 73.84 centimeters tall, anything up to that point, 90% of the children are at least that. So in other words, another way of saying that is 10% of the population is actually going to be taller than 73.8 centimeters. Okay, now let's go ahead and try to see how we would do this if we had only the table to our use that we could use. Now, notice that the initial statement is slightly different because of the fact that we're dealing with the standard normal distribution. We have to deal with the value of z. So we're saying that any particular value of z that's less than a is also going to give us this 0.9. So notice the similarity here, and the only difference is that this one here is a normal distribution, this one here is a standard normal distribution. So notice again that when I go ahead and calculate what the value of a is, by saying inverse norm of 0.9, that's going to give me a value of 1.28, 281. Now, notice that what I need to do next is I have to use this very valuable relationship here to determine what the x value is, being that this really is determining a z value. So what I need to do then is I say, okay, well, 1.281, which is the z value, is going to be equal to x minus the mean, which we know is 70, divided by the standard deviation, which we also said was 3. Now after this, it's just a matter of calculating what the value of x is, and just using our normal algebra techniques. We know that if we multiply both sides by 3 and then add 70, notice what happens is we come up with exactly the same value that we had here. So, the moral of the story then, is going to be important first of all for you to determine what question are you being asked. Are you asked to find a probability, or given a probability, are you finding a value? Based upon those questions, you can then go ahead, if you have your calculator, to calculate respectively. And if you don't have a calculator, then you need to go ahead and be able to use the table and also use this here to determine the values that you're looking for the random variable that you have. Okay, so good luck. Let's see if you can work on some of those questions, and I'll see you in class next time. Bye-bye.